We now present the words of two people from the mountain of mathematicians, the man who married geometry and algebra, and the man who brought us algebra in the first place, Rene Descartes and Al-Khwarizmi. Khwarizmi. Get that wrong all the time.
I hope that hereafter, those who are clever enough to make use of the geometric methods herein suggested will find no great difficulty in applying them to plane or solid problems.
In what is called analytic geometry, Rene Descartes changed forever the way we see algebra and geometry. That is, we now see them together. As with any development in a field of study or inquiry, Descartes is not only a giant figure, and he did not come up with analytic geometry completely out of thin air. That is, others were before him part of the process. But he did solidify the connection between the two branches of math, and we still celebrate his contribution in the name of the XY grid, the Cartesian coordinates. Pierre de Fermat is often considered a pioneer in this discussion.
Any problem in geometry can easily be reduced to such terms that a knowledge of the lengths of certain straight lines is sufficient for its construction. Just as arithmetic consists of only 4 or 5 operations, namely addition, subtraction, multiplication, division, and the extraction of roots, which may be considered a kind of division, so in geometry, to find required lines, it is merely necessary to add or subtract other lines, or else, taking one line, which I shall call unity, in order to relate it as closely as possible to numbers, and which can in general be chosen arbitrarily, and having given 2 other lines, to find a fourth line, which shall be to one of the given lines as the other is to unity, which is the same as multiplication. Or again, to find a fourth line, which is to one of the given lines as unity is to the other, which is equivalent to division. Or, finally, to find 1, 2, or several mean proportionals between unity and some other line, which is the same as extracting the square root, cube root, etc. of the given line. And I shall not hesitate to introduce these arithmetical terms into geometry for the sake of greater clearness. While reducing to a single construction all the problems of one class, I have at the same time given a method of transforming them into an infinity of others, and thus of solving each in an infinite number of ways. That, furthermore, having constructed all plane problems by the cutting of a circle by a straight line, and all solid problems by the cutting of a circle by a parabola, and, finally, all that are but 1 degree more complex by cutting a circle by a curve, but 1 degree higher than the parabola, it is only necessary to follow the same general method to construct all problems, more and more complex ad infinitum. For in the case of a mathematical progression, whenever the first 2 or 3 terms are given, it's easy to find the rest. I hope that posterity will judge me kindly, not only as to the things which I have explained, but also as to those which I have intentionally omitted, so as to leave others the pleasure of discovery.